Welcome to Engineering Society, the complete masterclass. Unlock your potential.
Before you can start solving complex equations or designing modern power grids, you need to know where your profession actually comes from. Engineering is a global story, and to truly understand your place in it today, we have to trace its roots back through centuries of human trial and error. Thousands of years ago, early societies were already solving massive physical problems. They carved, transported, and perfectly positioned roughly 2.3 million massive stone blocks using precise geometric math. When you look at the Great Pyramid of Giza, you are looking at an ancient masterclass in structural mechanics and surveying. For a long time, early engineers were military specialists, focused on building defensive walls and catapults. But by the 18th century, that focus expanded to civilian life. During the Industrial Revolution, inventors replaced animal power with mechanized iron. This shift massively expanded the reach of trade routes and accelerated the speed of global manufacturing. Nigerian history holds its own place in this timeline. By 500 BC, the Nok civilization in central Nigeria was already mining ore, building specialized furnaces, and reaching temperatures over 1,000 degrees Celsius to melt solid rock into usable iron. We can trace the sophistication of this early, intense heat processing right down to the intricate details of ancient Nok terracotta sculptures. Our ancestors were remarkably resourceful problem solvers. They practiced crop rotation to protect soil health and developed Fadama irrigation, a method of farming in seasonal floodplains that used trapped moisture to grow crops even when the surrounding land was dry. Artisans from the Kingdom of Benin poured molten liquid into complex clay molds to create highly detailed bronze castings that still stun metalworkers today. You are stepping into a legacy of innovation thriving in Nigerian soil long before colonization. This indigenous history is the foundation for everything you will study in your modern courses. This diagram shows exactly how the modern engineering profession is structured. It is a four-part family. At the top, you have engineers, trained in universities for complex design. Below them are technologists, who earn degrees from polytechnics to supervise those designs. Then come technicians, who handle installation and maintenance. Finally, forming the broad base, we have craftsmen, the skilled manual workers trained through apprenticeships and technical colleges. To pull off a major project, you need all four groups working in perfect balance. As those numbers appear next to each tier, you'll see the ratio for a healthy project team. For every one engineer doing the planning, you ideally need 5 technologists managing the process, 15 technicians setting up the equipment, and 60 craftsmen doing the physical fabrication. Let's apply this to a real-world massive project, like the nearly 12-kilometer-long Third Mainland Bridge. The university-trained engineer calculated the structural loads and planned the concrete spans. The polytechnic-trained technologist then took those blueprints, tested the raw materials, and scheduled out the daily production. But the bridge still isn't built yet. To actually get it over the water, the technician had to diagnose faults in the heavy lifting equipment and install the structural sensors. Finally, the craftsman, the welder and the concrete pourer, had to physically shape the steel and pour the foundation with their own hands. Because each role is distinct, they each have their own official professional home. Engineers report to the Nigerian Society of Engineers, or NESE. Technologists have APTEN, technicians have NIET, and craftsmen belong to NAEC. A design is only as strong as the team that builds it. From the engineer's desk to the craftsman's workshop, every tier contributes a critical link in the chain of project success. Governing all 4 of these groups is one ultimate legal authority, the Council for the Regulation of Engineering in Nigeria, known as COREN. They are the strict referee of the industry, setting the standards and maintaining the official register of who is actually qualified to work. If someone tries to practice engineering without the proper credentials and COREN registration, it is legally defined as quackery. In this profession, faking your qualifications doesn't just lose money. It leads directly to substandard materials, cracking pillars, and fatal building collapses. Fortunately, this system allows you to legally level up through hard work. A registered technician who goes back to school for a higher national diploma gains 5 years of experience, and passes a strict interview can officially move up the pyramid to become a registered technologist. Continuous education and official core and registration are the only legal, safe ways to advance your career and sign off on real-world projects. Eventually, you will face a moment where a client asks you to use cheaper materials or rush a design to save money. The first rule of the Engineering Code of Conduct dictates your answer. The safety, health, and welfare of the public must always take precedence over a client's demand for lower costs. Beyond the official code, there are unwritten laws for surviving in the workplace. You have to respect the experience of your senior colleagues. You must share credit when your team solves a problem, and you must deliver your contract work on time. Technical brilliance is invalidated if you compromise your ethics or lack basic professional integrity. When foreign technology transferred into Nigeria during the colonial era, it arrived as a double-edged sword. While it provided infrastructure like railways and coal mines, it also created a heavy dependency on imported machines and spare parts. For decades, the country relied on external expertise to keep local systems running. This dependency had global consequences. In 1975, the Lima Declaration set a bold target. Developing nations needed to produce 25% of the world's industrial output by 2000. Because we lacked indigenous manufacturing power, Nigeria and other nations fell far short. To address this failure, Nigeria launched the National Policy on Technology, creating agencies like NOTAP to regulate how we acquire foreign tech and NASRIDA to launch our own satellites. These policies provided the framework for moving away from simply buying equipment and toward building it ourselves through local research and assembly. Today, we are seeing the results of those structural shifts. We have transitioned from basic resource extraction to launching space satellites and building thriving digital startup hubs in cities like Lagos. These achievements are built on policies that insisted on local participation and technical education. This is where you enter the story. Your education is the final piece of this national blueprint. By practicing ethically and staying committed to local innovation, you will help complete Nigeria's journey toward technical self-reliance.
The engineers of the past built upon the foundations of history.
We stand on their shoulders, ready to shape tomorrow.
If you found this helpful, don't forget to like, subscribe, comment, and follow for more content like this, right here on the Chevatech channel.